Okay, problem number 6. Let's see what we got. A 15 ohm and a 34 ohm resistor are connected in parallel. Okay, and the potential difference is applied to the combination. Okay, so I have a battery, and I have a parallel. One's 15 and one is 34 ohms. So I would like to know what is the resistance in the circuit. That's A. So R net. Well, these are parallel, so I know 1 over R equals 1 over the total resistance of one branch, which is 15, plus the total resistance of another branch, which is 34. Now, this is, you could do the fraction game with this, find the least common denominator and scale up, or you can use your calculator. 1 divided by 15 plus 1 divided by 34. That is 9.6 times 10 to the negative 2. 1 divided by that answer gives me 10.4. This is the answer to A. Find the current in the system. Okay. Essentially I net. I know Ohm's law is V equals IR. And so they tell me that there is 33 volts in the system as per what the problem says. Okay, so 33 volts is equal to I, which is what I'm trying to find, and the resistance is 10.4. Oops, 33 divided by 10.04, which is 3.17 amps. There's the answer to B. Which means I only have one more thing. I would like to know what is the current. So I do know that the current leaves here, and the current that I found is 3.17 amps. It's really sloppy, sorry. 3.17. I know it's going to split here, and then it's going to come back together here. That's our definition of parallel. So let's look at our split. I would like to know how much goes down the 34 versus the 15. So we're going to do some ratio work. I asked you to choose the largest resistance, so 34. Divide that by each pathway. So there's two pathways. I'm going to divide 1 by 34. So 34 divided by 34 and 34 divided by 15. This is going to be a ratio of current. So I'm going to say I for the amount of current that goes through. I'm going to add them together and I'm going to get my total current. Solving this, 1I. So what does that mean? That means for every 1 unit of current or amp that goes this way, I'm going to have some number go this way, and that would be 34 divided by 15, which is 2.267 I is equal to, so for every 1 that goes here, 2.267 goes on this 15 ohm resistor pathway. The total I net was 3.17. So we add these together, 3.267 times I equals 3.17. I equals, so 3.17 divided by 3.267 and gives me an answer of 0.97 amps. Okay. Now, I'm not done. That's not answering my question. This is the I's for each of these respective pathways. So what that means is the one pathway got 0.97 amps, and the 15 ohm pathway got 2.267 times I. Or 2.2, technically it's 2.1999, 2.2 amps. That is the current through the 15 ohm resistor pathway. And that's what we're looking for. Okay. I showed you this, almost all circuits go R net, I net, and then we start working it. I strongly suggest that you, on your diagrams, you label where the current goes. label the overall resistance, especially in more complex ones. Goodbye.